Okay, so good morning, everyone. Today is the third day of our series, and in this lecture, we are going to learn the part 3 of the first chapter, that is real numbers and their decimal expansion. Now, to explain this, take three rational numbers such as 10 by 3, 7 by 8, and 1 by 7. Okay, now we are going to simplify or find out the decimal expansion of these three numbers. Okay. We will find the decimal expansion of the given numbers. Now, so number 1 is 10 by 3. Now 3 times 3 is 9. 10 minus 9 is going to be 1.0. Here comes 3 again. Then 9, 1, 0. 3 again, 9, 1, 0, and it will continue. Now here the reminders we get each time are 1, and the divisor here is 3. Similarly, we will take the next example, that is 7 divided by 8. 7. Now 8 is greater than 7, hence we must do put the quotient as 0 first. So 8 times 0 is 0. Here comes 7 again. We give a point, then it becomes 70. Now 8 times 8 goes 64. 10 minus 4 becomes 6. Then again 60. 8 7s are 56. Comes 4. 8 5s are 40. Here we get the remainders as one time we got as 6, 4, and 0. The house 0, I'll show it that to you. Now 8 times 5 is 40. It becomes 0. Therefore, reminders are 6, 4, and 0. And here the divisor is 8. Now comes the third example, that is 1 by 7. Again, similarly as we did on the example 2, we'll first put the quotient as 0. So 7 times 0 is 0. Here becomes 1, and we'll give a point, then it becomes 10. 7 ones are 7. The remainder is 3. Again 0. 7 fours are 28. 7 twos are 14. 6. 7 8 times 56. 4. 7 fives are 35. Then 7 sevens are 49. Here becomes 1 and 0. Then 1s are 7. Yeah, then it will be repeating again. Now here we get reminders as 3, first becomes 3, then 6, no, 3, then 2, then 6, then 4, then 5, and then 1. 3, 2, 6, 4, 5, and lastly 1. And here the divisor is 7. Now here we have noticed that now here we have noticed that the remainder either becomes 0 after a certain stage or repeating themselves. Okay, so in this case we have seen that the remainder becomes 0 after a certain stage, and here we have seen that the numbers are repeating itself. Number 2, the number of entries in the repeating string of reminders is less than the divisor. Now in 10 by 3 only one number repeats itself, that is 1, whereas the divisor is 3, and in 1 by 7 there are 6 entries, that are 3, 2, 6, 4, 5 and 1 in the repeating string of the reminders, and 7 is the. Now what does it says is, now in case of 10 by 3 the divisor is 3, hence we get repetition of only one numbers, that is less than 3. 1 is less than 3. That means the numbers which will be repeating will always be less than the divisor. Now in case of this one, 1 by 7, the divisor is 7, and the repeating numbers, which are the repeating reminders, are 3, 2, 6, 4, 5 and 1. 1, 2, 3, 4, 5, 6. There are 6 repeating numbers which is less than 7. Thus we can write that note, number of repeating numbers will always be less than the divisor. Now comes the third point. If the reminders repeat, then we get a repeating block of digits in the quotient. Now in this case the reminders kept repeating, okay, till here are the one set of repetition, and again from 1 it will be repeating the same set of repetitions again. Now if the reminders repeat, then we get a repeating block of digits in the quotient. Now that means if the reminders keep repeating itself, then we will get repeating blocks of digits in the quotient. Here 1, 4, 2, 5, 8, 1, 4, 2, 8, 5 and 7 is one block. Again we will get the same repetition as 1, 4, 2, 8, 5 and 7, and it will continue. Okay, so and lastly the fourth point, the pattern is true for all rational numbers that are in the form p by q where q is not equals to 0. Now this pattern, in which some cases we get repeating quotients and repeating remainders, while in some other cases we get while in other cases we get the remainder to be completely 0 after a while. This pattern is true for all rational numbers that are in the form p by q. That means either will be it of this form or it will be of this form. Now comes the case 1. The remainder becomes 0. If the decimal expansion terminates or ends after a finite number of steps, the decimal expansion is called as terminating, as in example 7 by 8 or 1 by 2. Now let's see the example 1 by 2. That implies 1 is divided by 2. Now 2 times 0 is 0. Here comes 1. Then we give a point and then again 0. 2 times 5 is 10. Now in this case, the decimal expansion terminates. It ends here. After 0, we cannot divide it any further. Now this type of decimal expansion is called as terminating decimal expansion. Now comes the case 2. The remainder never becomes 0. Now if the decimal expansion if the decimal expansion we have repeating blocks of digits in the question, we say that the expansion is non-terminating recurring. Now we have seen in this example 1 by 7. Now here we will have a repeating number of blocks in the question. Each time after the interval of 1, 2, 3, 4, 5, after 6 intervals, these whole numbers will repeat again itself. Now this type of decimal expansion is called as non-terminating recurring. It is called as non-terminating recurring. Now you might wonder, what does recurring means? Recurring simply means repeating. Recurring is equals to repeating. Okay, let's see another example of this case. Example 10 by 3. That means 3 divides 10. 3 times 3 is 9. Then comes 1. We give a point. We give a 0. Now 3 times 3 is again 9. Again the same thing is repeating. We get again 1. Now this will continue. Now since we get a repeating digit of quotient, that is 3 gets repeated each and every time. Hence this type of decimal expansion is called non-terminating recurring. Okay. Now comes an important note. Every terminating decimal expansion is rational and every non-terminating recurring decimal expansion are irrational. That means if the decimal expansion is of the type 1 by 2, then again 2 by 4, something like this, that means the decimal expansion are terminating, then they are rational. And if the rational numbers, not rational numbers, if the digits like 10 by 3 then again 1 by 7, etc. The decimal expansion are non-terminating recurring. Non-terminating recurring, and hence they are irrational. Okay, now here comes the textbook example 6 that says that show that 3.142678 is a rational number. In other words, express 3.142678 in the form p by q, where p and q are integers and q is not equals to 0. Okay, now let's solve this question. Let the color be now here we have 3.142678, which can be written in the form 3142678 whole divided by 1 2 3 4 5 6 1 2 3 4 5 6. Now since this is in the form p by q, which is in the form p by q and q is not equals to 0, hence 3.142678 is rational. Okay, now the next example, so that 0.3333, oh yes, one important note that I forgot to tell you all. In terms of recurring, yes. The usual way to show that a block of numbers repeat itself is to write in the form of bar. That is, if the numbers are 3.33333 and it will keep repeating itself, then we can write it as 3.3 bar. If the numbers are 1.472, 472, 472, 472, here 472 keeps repeating itself. 1.4. Now 472 keeps repeating itself, and hence we can write it as 1.472 bar. Now in this case, we are asked to show that 0.3333, that is 0.3 bar, can be expressed in the form p by q, where p and q are integers and q is not equals to 0. Okay, so now let us come to the solution. Let x equals to 0.333 dot dot dot. Let it be equation 1. Now we will multiply 10 with equation 1, which will imply 10x is equals to 10 times 0.333 up to infinity. That implies 10x equals to, now if we multiply 10, the decimal will shift one digit to the right. That implies it will become 3.3333 up to infinity. Now 10x equals to 3 plus 0.33333 up to infinity. We have broken it down. Now comes the real part. 3 plus, now in the equation 1 we have said that x equals to 0.3333. Now here we can write 0.3333 as x. We'll write it here from equation 1. That means 10x minus x is equals to 3. We have taken the x to the left hand side. That implies 9x equals to 3, which will become x equals to 3 by 9. That implies x is equals to 1 by 3. Therefore 0.3 bar, and a little separate color, 0.3 bar can be expressed as 1 by 3. Okay, another question with similar another similar type question. Let us do the solution. Again, we'll do it in the similar way. Let x be 1.272727 dot dot dot. Now earlier in this case, after decimal only one number keeps repeating itself, hence we have multiplied the whole equation with 10. Now in this case, since two numbers keep repeating itself, hence we'll multiply the equation 1 with 100. Similarly, if there are three digits that keeps repeating itself, we'll multiply it with 1000. Here comes the equation 1. Now we write 100 into equation 1. That implies 100x equals to 100 into 1.272727 dot dot dot. That implies 100x will become, now if we multiply 100, the decimal will shift to 2 digits. That implies 127.272727 dot dot dot. Again 100x is equals to 127 plus 0.272727. That implies 100x equals to 127 plus x. Now if we bring the x to the left hand side, it will become 99x equals to 127. No, it will not be right. That implies x equals to Okay, wait. I have done a minor mistake in this case. Here x is 1.2727. So we cannot take it like that. Okay, 127. So this will be 126. It will be 126 plus 1.2727. Yes. Now this will be 126 plus x, which again becomes 126 by 99. Yes, now this both numbers will get divided by 3. 3 times 33 is 99. 3 4s are 12. 3 2s are 6. That implies x will become 42 divided by, x will become 42 divided by 33, which can again further be divided by 3. 3 1s are 3, 3 4s are 12, 3 11, and x is equals to 14 by 11. Now we can write, thus 1.27 bar can be expressed as 14 by 11, that is in the form p by q, q not equals to 0. Okay, now comes another example in which we have 3 digits repeating itself after the decimal. Solution. Again, just like the previous, we will take as let x equals to 0.235 dot. Let it be equation 1. Now since here are 3 digits after the decimal, we will multiply it with 1000. 1000 times equation 1 implies 1000 times x is equals to 1000 times 0.235 dot. That implies 1000x is equals to, now if we multiply 1000, the decimal will shift 3 digits to the right, 1 2 and 3. That will become 235.235 dot. That implies 1000x is equals to 235 plus 0.235 dot. That implies 1000x will be equals to 235 plus x. That implies 1000x minus x, that will be 999x will be equals to 235. Again, x is equals to 235 divided by 999, which is in the form p by q. Thus, we can say that A number whose decimal expansion is terminating or non-terminating recurring is rational, and a number whose decimal expansion is non-terminating non-recurring is irrational. Okay, now comes an important question. Is pi a rational number? Now from the previous classes, we have written the value of pi as 22 by 7. 22 by 7. Now in this 22 by 7 is in the form of p by q. Then is pi an rational number? The answer is no. Pi is not an irrational number. Sorry, not a rational number. Not a rational number, because we take pi equals to 22 by 7 as an approximate value, not an exact value. You have to keep in mind that this is just an approximate value. Now if we divide 22 by 7, you will see that the value will come as 3.141592653, then 58, and it will keep continuing, which is non-terminating non-recurring. That implies that there is no repetition after the decimal. Now no repetition, that implies, okay, sorry, the non-terminating non-recurring, that means non-terminating, no repetition after decimal, which is, and thus uh, the value of pi is irrational. So now the next question says that find an irrational number between 1 by 7 and 2 by 7. Now to solve this, at first we have to find the decimal expansion of both the numbers. Now 1 by 7, if we solve, 7 times 0 0.01 the 7, 4 the 28, 3 the 2 the again 14, 6, 8 times 56, 5 times is 35, 7 the 49, 1, and then again this whole part will repeat itself. That implies 1 by 7 equals to 0.142857 bar, and 2 by 7 is equals to, now instead of solving it with long division, we can use a shortcut formula. Now 2 by 7, we can write it as 2 into 1 by 7. Now the value of 1 by 7 is 0.142857 n bar. Now if we multiply 2 with this, we will get the value of 7 times 2 is 14. 5 to the 10, 11. 8 to the 16, then 17. 2 to the 4 times 1, 5. And 4 to the is 8. 2 1 the 2. That implies 0.28571 5714 whole bar. Now, in case of 1 by 7, we have 0.1 at the front. In case of 2 by 7, we have 0.2. Now, to find a rational number, to find the irrational number, it should be between 0.1 and 0.2. Now, from the definition, we know that, for a decimal expansion to be non-terminating, to be irrational, it must be non-terminating, non-recurring. Non-terminating, non-recurring. Hence, the required number will be now let's see what comes between 0.1 and 0.2. Definitely 0.15. So we'll start it with 0.15. Now it should not be recurring. That means 15 should not be repeating. So let's put a 0 here. 150. Again we put 15. Then we put double 0. 15000. 150000. And it will go on. Thus, this is the required answer. Thus, it is the required answer. Okay, now let us come to the exercise 1.3. Now, the question here asks, write the following in decimal form and say what kind of decimal expansion each one of it has. Now, number 1, 36 by 100. Solution. Now, at first, we can simplify this 36 by 100 by dividing it with both numerator and denominator by 2. 2 1 are 2, 2 8 are 16, 2 5 are 10, 2 0 are 0, 2 9 are 18, 2 25 are 50. That implies 9 by 25, which can be written as 25. 25 times 0, and here comes 0. Now 25 times 2 is 50, 3 times would be 75. 55. Now 10 minus 5 becomes 5. 8 minus 7, 150. 25, 4 times is 100. 5 times is 125. 6 times is 150. Yes. Write the following decimal form now. Okay. So therefore the decimal form of 36 by 100 is 0.36, and say what kind of decimal expansion is has. And has terminating decimal expansion. Now example, question number 2, it says 1 by 11. Solution. So 1 divided by 11. Again, since 1 is less than 11, we first put the quotient as 0, then make it 10. Now again 11 times 0 is 0, it becomes 100. 9 is 99. 0 times 0, 100. 9. That implies 1 by 11 is equals to 0.09 bar. Where 0.09 is in recurring. Thus, the decimal expansion is non-terminating recurring. Now let us come to the third question. It is 4 times 1 by 8. 4 whole 1 by 8. Now this can be taken into fraction form by the formula numerator is equals to 8 times 4 plus 1, and denominator will be 8. That implies 4 whole 1 by 8 equals to 8 4s are 32. 32 plus 1 becomes 33 divided by 8. Therefore, divided by 8, it 1 it's 24. 8 4s is 32, comes 1, we give a point and it becomes 10. 1 is 8, 2, 8 2 is 16, 4, 8 5 is 40, 0. Okay. I'll write in the next page. Therefore, 4 whole 1 by 8 is equals to 4.125. and the decimal expansion is terminating. Now comes the fourth question, 3 by 13. Question number 4, 3 by 13. Now again, the numerator is less than denominator. Therefore, we have to first make. Now again, the numerator is less than denominator, and we will use the same process. 13 times 0 is 0. Then 3, we give a point, it becomes 30. 13 1 is 13. 13 2 times is 26. 4. Yes. Again, it becomes 40. 13 3 times is 39. It becomes 10. Again, give 0. It becomes 100. Now times 80, 13. 6 I think is 96. 6 3 I think it will carried over. 6 1 is 6 and 1 78. 13 7s are 7 8 9 91. So 13 7s are 91. It becomes 90. Then 6 78. Then minus 8 2 120. Again it becomes 13 times 7. Oh, ultimately we can say that 3 by 13 is equals to 0 0.23076 dot dot dot. That is the decimal expansion is non-terminating non-recurring. Okay, now question number 5, 2 by 11. 5 2 by 11. Again 0 point, we make it 20. 11 ones are 11. 20 minus 11 is 9. It becomes 90. 11 8 times is 88. Here becomes 2. Again ones are 11. 90 1 8. Therefore 2 by 11 is equals to 0.18 bar, and the decimal expansion is non-terminating recurring. Now comes the last question, 329 by 400. Now since 329 is less than 400, we have to again make the decimal after 0. Now it becomes 3290. Now what would be the nearest multiple of 400 that is nearest to this one? So 4 8s are 400 times 8 is, no, it will be greater. 400 times 7. 7 4s are 28, and 400 times 8 is 8 4s are 3200. 3200, 9 minus 09 be 900. 400 times 2 is 800. Now it becomes 1000. Again 2 times 800, it becomes 2000. 400 times 5, 0 0, 5 4s are 20. Yes, therefore 329 by 400 is equals to 0.8225, and the decimal expansion is terminating. Now comes the second question. The question says that you know that 1 by 7 is equals to 0.12857 bar. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are without actually doing the long division? Okay, now so let, oh shit. I have to write the question again. The question says that you know that 1 by 7 is equals to 0.142857. 142,857 bar. Can you predict what the decimal expansion of what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? Actually doing the long division. Now let us come to the solution part. Now it is given 1 by 7 is equals to 0.142857 bar. Therefore, 2 by 7 is equals to 2 times 1 by 7, that is equals to 2 times 0.142857 bar. Now we just simply have to multiply this whole number with 2. 7 times 2 is 14, 4, 1 carried over, 5 times 2 is 10, 11, 8 to the 16, 17, okay, 2 to the 4, 5, 4 to the 8, 2 1 the 2, 2 0 the 0. Therefore, the value of 2 by 7 is 0.285714. Similarly, we can do 3 by 7 as well. 3 by 7 is equals to 3 into 1 by 7. That implies 3 times 0.142857 bar. Now 7 times 3 is 21, 1, and having 2. 5 3 is 15, 16, 17. 8 3 is 24, 25. Now 3 2 is 6, and having 1, 7. 4 3 is 12. 2 on hand is 1. 3 1 is 3. 3 plus 1 becomes 4, and it becomes 0.47571. Now 4 by 7 is equals to 4 times of 1 by 7 is equals to 4 into 0.142857, which will become, now to save time I will use calculator. That is 4 into 0.142857 will be 0.571428 bar. Similarly, you can do it for 5 by 7 and 6 by 7. Now comes the third question. Express the following in the form of P by Q. The first is 0.6. Okay, now let x is equals to 0.6 bar. That implies x is equals to 0.66666 dot dot dot. Let it be equation 1. Now since only one number is repeating itself, hence we'll multiply equation 1 with 10. Equation 1 into 10 implies 10x is equals to 10 times 0.6666. That implies 10x is equals to 6.666, as the decimal will shift one hand to the, the decimal will shift to the one position to the right. Now that implies 10x is equals to 6 plus 0.6666, which can be written as 10x is equals to 6 plus x from equation 1. That implies 9x is equals to 6. That implies x is equals to 6 by 9 is equals to 2 by 3. Therefore, 0.6 is equals to 2 by 3, which is in the form p by q, comma q not equals to 0. Now comes the second question. 0.47 bar. Similarly, we'll let x is equals to 0.47 bar, which is equals to 0.4777 dot dot dot. Let it be equation 1. Now equation 1, we should multiply it with 100, because after the decimal here are 2 digits. Therefore 100x is equals to 100 times 0.4777 dot dot dot. That implies 100x is equals to 47 I think oh no, sorry, I have done a minor mistake. In this case, first we have to multiply it with 10, then we have to multiply it with 100, implies 10x is equals to 10 times 0.4777 dot dot dot. That implies 10x is equals to 4.777. Let it be equation 2. Now again we will multiply equation 1 with 100. This will become 100x minus 47.777, and let it be equation 3. Okay, so now equation 3 minus equation 2. That means we subtract the third equation. Sorry, we subtract second equation from third equation. That would be 100x minus 10x is equals to 47.777 minus 4.777. That implies 90 times x will be equals to 47 minus 4 would be 43, right? Okay, so 47.777 minus 4.777 would be 43. That implies 90x is equals to 43. That implies x is equals to 43 by 90. Therefore 0.47 bar is equals to 43 by 90. Okay, so now comes the third question. Similarly, let x is equals to 0.001001 dot dot dot, and let it be equation 1. Now in this case we'll multiply equation 1 with 100. That will become 100x is equals to 1.001001 dot dot dot. That implies 100x is equals to 1 plus 0.001001 dot dot dot. That implies 100x is equals to 1 plus x from equation 1. That implies 99x is equals to 1. That implies x is equals to 1 by 99. Therefore 0.001 bar is equals to 1 by 99, which is in the form P by Q, where Q is not equals to 0. These are the type solutions of number 1, number 2, and number 3. Okay, wait. Hmm. Okay, now comes the question number 3. Similarly, okay, now comes the question number 3. Let x is equals to 0.001001 dot dot dot, and let it be equation number 1. Now, as we have 3 digits after the decimal, we'll multiply it by 1000. Implies 1000 times x is equals to, now since we multiplied it with 1000, the decimal will come 3 digits to the right. 1, 2, 3. That would be 1.001001. Now this will become 1000x is equals to 1 plus 0.001001 dot dot dot. That implies 1000x would be equals to 1 plus x from equation 1. That implies 999x would be equals to 1. Therefore x is equals to 1 by 999. Thus 0.001 bar is equals to 1 by 9999, which is in the form P by Q, where Q is not equals to 0. Okay. Now let us come to the question number 4. Here it says that express 0.99999 in the form of P by Q. And are you surprised by your answer? With your teacher and classmate, discuss why the answer makes sense. Okay, now let's solve this. Solution. Let x is equals to 0.99999 dot dot dot. Let it be equation 1. Now since only one digit is repeating itself, we'll multiply it with 10. 10 times equation 1 implies 10x is equals to 9.99999. That implies 10x is equals to 9 plus 0.999, which will become 10x is equals to 9 plus x. That implies 9x is equals to 9. That implies x is equals to 1. Therefore, 0.999 is equals to 1. Now, it is written here, yes, we are surprised to get an integer 1 because after decimal 9 is repeatedly infinite and this will tend to an integer. Okay, now comes the question number 5. What can be the maximum number of digits to... Now comes the question number 5. What can be the maximum number of digits p in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Now since the division is very long, I am not going to do that. You can check it here. Now after the decimal, the number which will be repeating are 058823529411767. That means a total of 16 digits is being repeated here. Now let us move forward to the next question. Write 3 numbers whose decimal expansion are non-terminating, non-recurring. Whose decimal expansions are non-terminating and non-recurring. Okay, now let's come to the solution. Number 1 we can write as 0.10, then 100, 1000, 10000, 10000, and it would continue to go on. The second example we can write as, okay, so 250, 2500, 25000, 250000, and it would continue till infinity. And third, 0.4970, 4970000, 4970000, 4970000, and it would continue till infinity. Okay, so here are some different examples. All are valid, just it has to be non-terminating and non-recurring. Okay, now it says find 3 different irrational numbers between 5 by 7 and 9 by 11. For this, we have to write the decimal expansion of both the given numbers. 5 times, so 7, 7 is 49, here comes 10, 1 is 7, remainder 3, 7 4 is 28, 2, okay, 7 3 is 7 2 is 14, 7 is 14, 7 8 times is 56, then again comes 40, 7 3 is 21, 7 4 is 35, 7 5 times is 35, here it becomes 50. Okay, now this will continue itself. Therefore 5 by 7 can be written as 0.714285 bar. Sorry. Now the second part, which is 9 by 11, can be written as 0.11 times 8 is 88, 2 1 is 11, 90, again 8 is 88, 21. Therefore 9 by 11 is equals to 0.81 bar. Therefore we need to find irrational numbers between 0.714285, 0.714285 bar and 0.81 bar. Now broadly we can see that it is 0.7 and 0.8. Now what comes between 0.7 and 0.8? Obviously 0.75, 0.76, 0.77. Hence the required irrational numbers are the required numbers are 0.720, 7200, 72000, and it will continue. Then 0.730, 7300, 73000, and it would continue. And lastly 0.750, 7500, 75000, 75000, and it will continue. This is the required answer. Okay. Now comes the question number 8. It is similar to question number 7, hence I won't be solving it. You can see the solution here. Now comes the last question of this exercise. Classify the following numbers as rational or irrational. Now number 1, under root of 23. Solution. Since 23 is not a perfect square, therefore under root of 23 is irrational. We have learned this in the last lecture. Now question number 2, it says square root of 225. Solution. 225, it can be written as 5 4s are 20, 5s are 25, 9s are 45, 3 3s are 9. It is 5 into 5 into 3 into 3. Therefore, 225 is a perfect square. Thus, under root of 225 is rational. Now, third question, 0.3796. Third, 0.3796. Okay, we have learned this in today that we know if the decimal expansion of any number is terminating, then it is rational. Therefore, 0.3796 is rational. And question number 4, 7.478478. 7.478478 dot. Solution. Here, the decimal expansion is non-terminating but recurring. Therefore, 7.478 bar is rational. And lastly, question number 5. 0.10100 1010001000. Here, the decimal expansion is non-terminating non-recurring. Hence, the given number is irrational. So, in this lecture, we have done the theory behind exercise 1.3 and we have completed exercise 1.3. In the next lecture, we'll continue from exercise 1.4.